All right, so we are now starting C2, Applications and Problem Solving of Linear Quadratic Systems. Okay, you've seen some of this in grade 10, so let's do the first example. You have seen this in grade 10, or at least 95% of it. And maybe when I read it, you'll remember this type. A bus company has 4,000 passengers daily, each paying $2 for a fare. Every time they increase the fare by 15 cents, the company loses 40 passengers every day. That should sound familiar. You did these kind in grade 10. If the company needs to take in $10,450 per day to stay in business, what fare should be charged? Okay. Taking in money as a business is called revenue. You learned that in grade 10. And how you calculate revenue is by calculating the amount of money that you take in. It's quite simple. You're taking in $2 for every passenger. So you're taking in price times number sold, or price times quantity, or whatever you'd like to say. So in our case, the revenue function will be our price times our number sold, but not until we consider this adjustment. So the adjustment that they're considering paying is, or applying, is having each person pay $2.15 rather than $2, or maybe $2.30 instead of $2. That's 2 increases of 15 cents. 3 increases of 15 cents is 45 cents, so they would consider $2.45 as the new price. So they're increasing the price in increments of 15 cents, and they want to see what that does to their revenue. They know that they're going to lose passengers if they do that, but there might be a sweet spot, and that's what we're trying to find. So in order to write a revenue function for this particular problem, we need a let statement. The let statement is always based on the word each or every. For every 15-cent increase, or for each 15-cent increase, that's what's going to drive our let statement. So I'm going to use n. Let n represent the number, this is important, the number of 15-cent increases. Okay. I might choose to increase it once, so the number is 1, in which case the fare would be $2.15. If I increase it twice, the fare would be $2.30. If I increase it 3 times, the fare would be $2.45, and so on. So my revenue function for this would be revenue as a function of the number of times I increase this price. The price would be $2. Increase means plus some number of 15-cent increases. That's the price. Current price plus some more, but I don't know how much yet. Now, if I do that, the number sold is 4,000 when I have a $2 fare, but I'm going to lose 40 passengers. Lose means subtract. 40 passengers every time I increase it by 15 cents. So 40 times n is how many passengers I would lose. So there's my revenue function. Okay, it says if the company needs to take in, that means revenue is $10,045, what fare should be charged? So now I'm being given the revenue. So I'm given this number. I replace revenue with it, 10,450 equals. And then I think I'm going to go ahead and expand these binomials by foiling. I'll get 8,000 minus 80x plus 600x minus 6x squared. Okay, so that's quadratic. Every quadratic is solved when one side is 0, in case we are able to factor it and we need to use the zero product rule. So let's move the 10,450 over to this side and actually organize a little bit better. I'm going to put the negative, actually, you know what? I'm going to move everything to this side and put the 0 on the right. So I'll get positive 6x squared minus, these two come to 520, so negative 520 on this side. And then when I bring that 8,000 over, it will go negative, and when I subtract 8,000 from 10,450, I get 2,450. Okay. Quadratic. How do you solve a quadratic set to 0? You have options. You can factor it, if you can, and if you can't, then you use quadratic formula. I'm pretty sure 2 goes into all of these things since they're all even. And I know 3 doesn't go into that, so I can't get any more out of there. Okay, do I really want to look for a number that multiplies to 3 times 1,225 and adds to negative 260? I do not. I don't know about you, but that doesn't sound like something I want to do. So whether it's factorable or not, I think I'm still going to go for quadratic formula because the numbers are just too big. You can do that. Okay. So let's go ahead. Here's my A, here's my B, here's my C. Oh, I changed to X, didn't I? Darn it. Let me go back to N's since that's how I wrote my let statement. That's better. Okay. So my A is 3, my B is negative 260, and my C is 1225. When I'm using quadratic formula to solve for n, quadratic formula gives me my n values immediately. So my negative B, negative 260 is positive 260, plus or minus negative 260 squared minus 4AC, all over 2A. Calculator time. I've punched this in already. It comes to, oh no, I didn't punch it in. Let me do that. You do it too. I gotta grab my calculator. Hold on. Okay. I'm not going to bother with the negative. 260 squared is going to be positive no matter what. Minus 4 times 3 times 1255. 1225. 52,900. I take the square root of that. I get 230. Nice. 260 plus or minus 230 over 6. All right. Luckily, we got a positive number underneath the square root symbol. That means we can do it. We will get 2 answers. N equals, let me take the plus version first. If I add these two, I get 490 over 6, which is 490 over 6, 81.7, let's call it. And if I subtract 260 minus 230 is 30 over 6, and n would equal 5. Okay, so let's remember what these n's are. I'll call this n1 and n2. If you forget what they are, let's go back to the let statement. N is the number of 15-cent increases. This says I'm increasing the price by 15 cents 81.7 times. That's insane. This says I'm increasing the price by 15 cents 5 times. So let's see what is more likely. The price is $2. N1 says to increase it by 15 cents 81.7 times. My goodness. Punch that into your calculator. You'll get a new price of $14.26. The number of passengers then would be 4,000 minus 40. This is our number sold expression. 4,000 minus 40 N. Now we know that N is 81.7. That drops our ridership all the way down to 732 people. Okay, not very likely. Let's try the other one. Our price function is 2 plus 0.15 N, but this N is 5. Punch that into your calculator and you'll get a bus fare of $2.75. Number of passengers then, 4,000 minus 40 N, but now we know N is 5. $4,000 minus 200, 3,800. Which makes more sense? Mathematically, the point 14.26, 732 is on the parabola, and so is 2.75, 3800. Those are both on the parabola. This parabola would represent revenue generated of $10,450. But in practical terms, if you read the question and you apply common sense and what your life experience tells you is nobody's paying $14.26 to get on a bus. So $2.75 would make more sense. Now, if you could convince the general public to pay that, which according to this survey you can, you would drop your ridership all the way down to 732. Maybe that is desirable. Maybe you don't have to clean the buses often, or maybe it's not as crowded, or who knows. But nonetheless, these are both valid answers. I would just argue that this one makes more sense. And that's it for this question.